Hey everyone, and welcome back to our next Unreal Engine 5 tutorial. In this episode, we're going to be focusing on materials. Let's remember that materials are those types of assets that we can apply to meshes to create the impression that they are made out of something. So let's start at the very beginning. If I wanted to make a new material, I'd start out here in my base content directory, and I'd probably start by making a new folder like this and renaming it My Materials, like so. I could further organize this, I suppose, if I open this up and made another new folder, let's say Small Meshes. Materials that are applied to like relatively small objects as opposed to gigantic things like oceans and land masses. So I'll make another folder for those, and I can make as many subfolders as I need. Let's say large meshes and landscapes, like so. So let's start with something very, very basic. Here inside my small meshes folder, we'll double click, and then I will right click and find that I have the option under Create Basic Asset to select this item labeled Material. So I will. I'll name this one M underscore, that is the naming convention for a material, M underscore example. Okay, we're going to make our very first material using M underscore example. So I'll double click that and I'm going to dock this window. This is the material editor. It looks a lot like a blueprint graph, and it is going to be node-based, so it feels like working in Blueprint, but technically this is not a blueprint. It's the material editor graph. So anytime you create a new material, it will come with this node, which is referred to as the result node, okay? And all of these pins that are exposed on the left can control different properties of what that material will look like when applied to any given mesh. So let's start at the top, base color. Well, if I wanted to make a material that was a specific color, that's done using a constant 3 vector. So I could either right-click and search for constant, and you can find it right there, but it's something we need frequently. And if I need a constant 3, I will hold down the number 3 while left-clicking my mouse. And that's what a constant 3 vector node looks like. There are 3 coordinates, x, y, and z, but if we're going to be using this to represent a color, think of the x coordinate as being red. Think of the y coordinate as being green, and think of the z coordinate as being blue. I can directly enter values here. For example, if I wanted something to be fully red, I could just type the number 1 and leave the other 2 at 0. Or if I wanted something to be completely green, I could leave red at 0 and enter a 1 for green. Actually, you're going to see it here. And in a moment, you're going to see it on this preview mesh. So focus right in this little area for the time being. And if I wanted it to be blue, I could zero out red and green and type a 1 for blue. Or, because all of these 3 are floats, I can have any combination of red, green, and blue that I want. A convenient way of selecting a color is just to double-click on the node, and you can do a number of things. For example, you can use this control on the color wheel until you see the preview of the color that you want, which will appear right here. Okay? Another way that you could do it is to use the eyedropper tool. If you see somewhere in here a color that you want, you can select it with the eyedropper, and now we have that color. But for this first example, I'm going to make mine fully red, I suppose. So we'll type 1, 0, and 0. And now it's fully red, and I'll hit OK. I could have done exactly the same thing in these 3 entry fields if I wanted to. Now, to project this color onto this preview mesh, all we have to do is to use this white node here, which is the RGB output, and connect it to the base color pin on the result node, like that. And this preview mesh defaults to being a sphere, but it could be a cylinder, and it could be a plane, and it can be something like a box. And navigating that viewport takes a little getting used to, but you can get an idea of what things are looking like. Okay? So I'll go back to the sphere, and I will now touch on some of the other nodes that are important when you're just dealing with things that are solid colors and other types of starting points for making materials. For example, let's suppose that I wanted to make something look like it is a piece of metal. What I could do is I could set all 3 of these to some middle gray value. They would have to be the same, something like 0.4 on the X, 0.4 on the Y, and 0.4 on the blue. Okay, so we've got like a middle gray value. Now, let's suppose that I want to make this look like a piece of metal. There is this metallic parameter that it defaults to 0. But look what happens when I set it to 1. All of a sudden, this takes on a somewhat more metallic appearance. But I wouldn't exactly say that it looks like metal. Not just yet, anyway. Because there is another parameter that is of great importance when you're trying to create a metallic appearance. And that is this roughness parameter. It defaults to 0.5. Now, roughness literally means the roughness of a surface. And this style of creating materials is known as physically based rendering, or PBR materials, because we are using physical features such as the roughness of a surface to influence the appearance of our final material. If this roughness is set all the way to 1, it's not going to look like metal at all. It's going to be very flat. But if I were to set the roughness to a value of 0 or something close to 0, let's try 0. Now that looks like a thing that is made out of metal. And if I increase the roughness incrementally, let's try 0.1. It's not quite as shiny. What about 0.2? You can see what's happening. It looks like metal for sure, but now it looks more burnished. Let's see, 0.3. At some point, it'll probably stop looking very metallic. We're probably getting close to that threshold right about now. So let's go 0.125. Yeah, I think I like that. So if we were to stop here, this is okay. We could say that this is a complete material, and then I'm going to hit apply for it to compile the shader, and then save it. Now, if I go back out to my map, here is this material that I've created, and I can now apply this to any mesh in the world. So for example, I can drag and drop it onto a mesh that I see. Or conversely, let's suppose that I have a mesh that is selected in the world. So let's look at one of these other cubes, for example. Let's do this one. I could select it and notice that there's a material element in the details panel. So likewise, I could just drag the material there. Or I can simply pick the object just by clicking on it while in selection mode. If I click on it, then I get the same opportunity. In the details panel, I could just apply that material just as easily. Okay, so I can make anything out of metal now that I want to, like this ramp, and it will stay that way even if I go into play mode. You can see here is this metallic looking ramp. And we can always go back, by the way. If I wanted those to be very, very mirror-like, I could set the roughness to 0. I'd have to hit apply again and then resave the asset. But now those are going to be very, very shiny. You can see that I can even kind of see a reflection of myself, sort of, and the rest of the world. We could make that more perfect if we wanted to, but it requires a slightly different technique. Okay? So let's set that back to 0.125 on the roughness. 0.125. And now we have our very first material. Okay, so in base color, on the roughness parameter, our limitation is not only a constant 3 vector. It's not only that. And by the way, like I said, this could be any color. So for example, if I stuck with my original red concept, that would be a 1, this would be a 0, and this would be a 0. So now it looks a little bit like red metal. And if the roughness was set to 0, it would look a lot like a Christmas ornament or sort of like an idealized red metallic thing. Okay? But this base color node is not limited to constant 3 vectors. We can also make materials based on photographs. Photographs are sometimes referred to as texture samples. They are photographs that are basically prepared in a specific way. And casually, again, we refer to them as textures or texture samples. A great place to obtain texture samples is through the use of Quixel Bridge. So in order to use Quixel Bridge, what you want to make sure is that in your settings dropdown to search our plugins and type a search for Quixel and make sure that the Bridge plugin is checked or set to true. I think that it is by default now, but in case yours is not, double check and make sure that's true. If it was false before, as soon as you make it true, the editor will report to you that it needs to restart. So just allow it to do that and you should be fine. Once you've done that, you should be able to go here to the window menu and look for this Quixel Bridge. This will not appear in this window unless the plugin is already enabled. So if you wanted to, without having to search through the plugins, I suppose you could just see if it's there. And if it is, just click it. Now, in my case, it did not appear, and that is a bug. So I'm going to hit pause, and I'm going to save everything where I am right now. The only thing that I will change is that I'm going to shut down and resume the recording as soon as I restart the editor. So this will just take a moment. Okay, I'm back, and the only thing that I did was to restart my editor. Now I'll go to the window menu, and I'm going to try again. Quixel Bridge, and there it is, popped up for me. Yeah, that will happen occasionally. It's going to want to try to force you to go to Fab, but I still find that using Quixel textures, they're more easily accessible from this interface than from Fab. So I'm going to click Stay Here, and this is dockable, so I can put it right there at the top of my screen and switch back and forth easily. This does require you to sign in. I happen to be signed in right now, so you can sign out. But if it says sign in, you're going to want to do that using your Epic credentials. Okay, so now let's find, some textures to work with. And what we'll do is we're going to go into surfaces, into that category. And there are a number of different subcategories there. Let's go for brick. Let's use brick. And I'm just going to look through this and find something that appeals to me. Okay, so this caught my eye just now, brick wall. If I click on that, left click, then I have, let me just get this out of the way. Then I have a few options. I can select the quality level that I want. The highest quality, as I understand it, is 16K, then 8K, and then 4K, and then 2K. The argument for very, very high resolutions is if you have an extremely powerful system and you're using that for something that has to look absolutely lifelike, such as a feature film or something of that nature. We're going to go ahead and use a 2K material, and that is to say I'm setting it to medium quality. And then we will have to download this. So I'll click download. We'll see how long that takes. Shouldn't take very long, especially at medium quality. As soon as it's ready, this add button will illuminate, and I can click the plus button to add it into my level. And there it is. Okay, so it comes with a few things. One of the things that it comes with is a material. Okay, so if, for instance, I were to go to the Place Actors panel, and I want a basic shape, let's just drag a cube into the level like so. Cubes are easy to work with because they can be scaled into things like walls, for instance. I'll use my scaling tool, make it a little bit thinner, and I'm going to increase it on this axis, and oops, wrong axis. I grabbed the wrong. Let me get down here. Just make it taller, make sure that it's not going underground either. And I'll hit end, snap it to the ground. If I wanted to, I could apply this material to the wall in the same way that we applied our other material to this wall. I can select it and drag my material over to the material element in the details panel. Or if I didn't want to do that, I could just drag it right on top of the mesh, and that also works. All right, so we can see now that we've got a version of this brick material on this wall, and it looks pretty good. Nevertheless, I would like to show you how to use texture samples because any material is going to come with a few different other assets that I want you to know how to use. In particular, what's called the albedo map, okay, or sometimes just referred to as base color. As a matter of fact, if you look at this pop-up, all the way at the bottom, it says 2K albedo EXR, and EXR is an image file format, just for your information. And then we have another item here, which is called a normal map. And it too is an EXR image. It doesn't have to be EXR, but that is the highest quality uncompressed image format, especially compared to other formats like JPEG, which do not yield as terrific results. We are not going to be talking about what's contained inside of this map today. This is slightly beyond the scope of this tutorial. This is called an ORD map or a packed map. And it has other information contained in it that indeed can be useful in a material. But for our purposes, we're not going to be making use of that today. We're going to be mainly talking about things like albedo textures and what are known as normal maps. So let's make our own version of this material. So right next to it, I will right click and I'll make a new material. And I'm going to call it M_my brick wall. And if I double click that to open it, it will open and I can use the tab to dock it. And we see the same exact attributes node, not attributes, excuse me, the same exact result node as it's called. So I can bring up my content browser here, and I did that with Control Spacebar. And this is located inside of the generated megascans folder. When you import textures or any other types of assets into Unreal Engine from Quixel Bridge, they're going to go inside of a folder that it will create itself called megascans. So let's open that up and then get into our surfaces. And then one more folder down, we're going to find our textures. The first one that I want is the albedo. This is referred to as the albedo map. And I'm going to drag that into the material graph. Now, this is not a constant 3 vector. Technically, that is an image. It's an EXR photograph of some actual brick. If I take the RGB out and plug that into base color, you can see that now it's projected onto this preview mesh here. So let's make that into a cube, right? You can see it looks a lot more brick-like, okay? Let's see if I can rotate that. A lot more brick-like. And if I go back to the content browser, the normal maps are usually going to say _n at the end. And by the way, base textures that are, like albedo maps, sometimes they're also known as diffuse maps. So that's what the letter D means. Okay, so anyhow, I'm going to bring the normal map also into my material graph. And the purpose of normal maps is to use gradations of color to influence how light interacts with the object to make it have an appearance that is more 3D. It doesn't actually give it 3D geometry like the little nooks and crannies between the bricks, but it will influence how light interacts with it to help create that illusion. So if I were to take the RGB out of the normal map and plug that into the normal input, now this is looking a little bit more realistic, right? It's really not 3D, but it is changing the way that light interacts, and that's even more obvious when put into the scene. I can still control things like my metallic and my specular and my roughness. Let's set that to fully rough. Brick is pretty rough. I think that's appropriate. Specular, I'm going to set that to 0. It should not be very shiny. And we can see something that looks pretty convincing as brick. All right, except for when we look at these sharp corners. And that's not a bad-looking material unto itself. I want to, though, give you an even better understanding of what this normal map is contributing to this. So temporarily, let's disconnect the albedo map. I'm going to Option-click or Alt-click. And you can see that we can still see the influence of the normal map. We can still see what it's doing there on this mesh. It's not actually changing its geometry, but it is changing the way that light interacts with that geometry. And the combination of the two can give it a much more 3D-like appearance when it's applied to a mesh. So now we've got that. I'll hit Apply and Save. And now if I take my brick wall and place it onto this mesh, now that's what we have. I dare say I like it a little bit more than what we had before. Now, I want to also point out that we may not like the size of these bricks, and it is also true that if I were to scale this mesh using our scaling options, you can see that they stretch or squeeze. Okay, so let me just kind of make this, I'll leave that, I suppose, just as it is right now. If I don't like the size of these bricks relative to the mesh that they're applied to, we can control that. And we do it at the material level using something known as UV mapping. UVs are just a coordinate system for tiling a texture when it is projected onto a given mesh. So I still have this material docked. In order to control the UVs, I need to apply them equally to our albedo texture and also to the normal map so that they are in alignment. For a basic material, you're going to need a couple extra nodes here. The first one is going to be called a texture coordinate node. You can get that easily by right-clicking and just type COORD. And that will give you texture coordinate, okay? And the texture coordinate, if you twirl it down, you can see it defaults to U tiling 1 and V tiling 1. This is the vertical and horizontal scaling of that image, okay? So that's how you can think of U and V, okay? That is just a vertical and horizontal tiling. We don't have to look at that all the time, because the workflow for this under normal circumstances is that you will follow this with a multiply node, multiply, and that's just simple arithmetic multiply. And I'll plug the texture coordinate output into the A of the multiply. I will then take the output of the multiply node and connect that to the UV inputs of the diffuse map or albedo map and the normal map. If I hit Apply and Save, nothing will change. However, what if I were to change this number, this constant? What if I made it into a larger number? Would the bricks get larger or would they get smaller? This is going to scale them, keeping their original proportions. So if I type 2 before I actually hit enter, I want you to understand what's going to happen. It is going to take the same texture and multiply it by 2 so that it has to tile twice over the same unit area. So therefore, what we see now is only tiling once. If I make it tile twice, then the elements of the image that you see will indeed become smaller to your eye. So let me hit enter. Take a moment, and now we've got a greater number of bricks. So let's go back to 1, just for comparison, and they're bigger again. What if I want them to be bigger still? I could try 0.75, or how about 0.5? 0.125. And really make them as large or small as I want. But let's default that back to 1. And we are going to create an ability to control this sort of on the fly. If I want to, I can make a single value constant that I can control outside of this material graph. So I will, in the same way that we held down 3 to create a constant 3 vector, what I want in this case is just a constant 1. It's not really a vector, I guess, but it's a constant 1. So I'll hold down 1 and left click. And now I can enter, let's say we'll start with a 1 here. And I will plug that in. Now I can set the number from within this node. But even better, I can declare that this node is a parameter. So I can right-click it and convert to parameter. And I can give it a name. I can call this UV scale, for example. And it has a default value of 1, which is fine. Apply and save. Now, in order to adjust that on the fly, what we need to do is not actually use the material that we just created. Instead, we use a sort of a version of it that is a lot more efficient, and it doesn't look any different, which is the good news, but it's something that allows us to adjust things like the UV scaling from outside the material editor. And this asset is known as a material instance. Now here is my m_my brick wall, but I want to right-click on that after I'm satisfied and create a material instance. And I don't even bother renaming it. Sometimes I do. I take it back. I usually like to use the prefix mi, even though it adds inst at the end. Mi is really the correct way to do it. Now there's my material instance for the brick wall, and I can just place it on there, and it's not going to look any different. I could also have done that over here. Doesn't make any difference whatsoever. But if I open up my material instance, I can drag it off of the dock, go back to my main viewport, and pull over this pane manually. Ultimately, a material can have lots of parameters, but we only made one, and it is a global scalar parameter that we called UV scale. So to view that, I can just click on this disclosure triangle and enable that parameter that we made. And now, in real time, I am able to adjust the UV scaling. Please take note that this is not scaling the mesh, right? The mesh isn't getting bigger or smaller. It's just scaling the UVs of the albedo map and the normal map so that they remain aligned and I can get the exact size that I want. However, we still have not solved the problem of stretching and squishing. If I needed to make this mesh a different size, then we are going to deform our textures if their size is based on UVs. So what we'll do is we are going to set that back to 1. And I don't remember exactly what proportion this was, but I guess I'll just eyeball it. And now I will, let's see, I'm going to make some room. I'm going to delete this mesh over here and grab this one. And with my translation tool, if I hold down Alt or Option, I can drag a copy of it over here. And this is just another instance of the same mesh. But I'm going to do something a little bit different on this second one. I'm going to make a special kind of material called a world-aligned material. World-aligned materials are also sometimes called triplanar materials. To do this, I'm going to use my original master material, right-click and duplicate it. And I might want to add something to the name to indicate that it's world-aligned. First of all, I'm going to delete the number 1 that it put at the very end. And I don't know that there is an official prefix for world-aligned materials, but my prefix that I always use is WAMAT. And to me, that stands for world-aligned material. Okay, so whenever I make a world-aligned material, it's very, very obvious to me because the prefix is always WAMAT. And right now, if I were to place this onto the second mesh, you're not going to see any difference because it's literally a copy of the first parent. So if I open this now, we are going to put this together differently. And it's not going to use traditional UVs. So let's delete all of that for the time being and Option-click our 2 texture samples and start fresh, okay? So we need to make some room on the right. And for our albedo map, we need to search for, and I did that by right-clicking, world-aligned until you see world-aligned texture. This is the node that you need. And you need a similar node for the normal map. So you'll right-click and your search is going to be for world-aligned, and until you see world-aligned normal, and you'll probably notice that they're very, very similar in appearance. However, they're not identical. All right, so we have our texture inputs for these, but notice that if I pull out of the RGB pin, it tells me that these are not compatible. If we read this very carefully, it is a texture 2D, and what it wants is something called a texture object. And texture objects are not as scary as they sound because any texture sample can be very, very easily converted into a texture object. All you need to do is right-click on it and use this option, Convert to Texture Object. I'm going to also do that for the normal map, Convert to Texture Object. And now they're compatible. So I'm going to feed those textures into the texture object pins, and I can take the XYZ output for the first one, plug it into base color, and the XYZ texture out of the normal map and plug that into the normal. I did the wrong one, XY texture. No, I meant XYZ texture, right? Just like that. And let's change the preview mesh to something more appropriate. Okay, in this case, our texture size is going to be determined by a constant 3 vector. So we'll do what we did before, and I will hold down the number 3, and I will make that. Now, as far as the starting values are concerned for this, I want to point out that while I'm in Quixel Bridge and I am downloading something in the first place, it will give you dimensions here in meters, okay? So it can be very, very useful to, usually they're square. I don't know why this one is rectangular, but a lot of the times it's 200 by 200 or whatever. Or 2 by 2 meters would be 200 by 200 centimeters. So this is in meters, 1 by 2. So I want to take note of that because in my world-aligned material, if I rotate this and I look on the x-axis here in the legend, right? I would like to set my x-axis, if that's going to be the side that I'm looking on. As a matter of fact, especially if I consider this to be the front, okay, then the x-axis excuse me, the x-axis is currently facing us, beg your pardon. So on this axis, I think it said it was 1 meter. So what I'll do is I will set the size for the x-axis to 100 unreal units, and that's 100 centimeters. And on the y-axis, let's look at bridge again. It was 200 centimeters, or 200 unreal units, 200, okay? So now this is the actual scale that these bricks were meant to have from the beginning, okay? We didn't even control for that in our UV scaling, right? And for our z value, I suppose if you were to set that to 100, that would probably be appropriate, or even 200. Okay, that's not going to change their tiling here. But now what we can do is we can take the RGB out of here and plug that into the texture size parameter of these world-aligned nodes. Now, one thing, if I apply and save this, I want to show you something, the difference in behavior. We're not quite done making the material yet, but now that this one has this world-aligned version of the brick wall, and this one doesn't, I'll remind you that if I were to scale this one, let's say up or out or whatever, you can see that it deforms the proportions, stretches and squeezes. But if I have a world-aligned material, let me just make a little bit more room for it. If I have a world-aligned material and I decide I want to resize the mesh, this is fantastic because it does not deform by stretching or squishing any of the textures. So this is fantastic. This is not as fantastic for things that have kinematics, because what happens, this is happening in world space. So if this object has to move, what you're going to see is that the texture that's projected on it is going to sort of swim. I don't know how else to describe that to you. So, but it's great. Oop, I didn't mean to delete that. I meant to hit end. But it's great for, like, let's say you're building a structure of some kind and there are pieces that are not going to move. You could have two versions of this material, this same material, one of them being world aligned so that I can build the major pieces, the walls and the whatever else have to be made out of the same stuff. But if I have one that has to move, I could make a traditional version of that material using the traditional UV method. Okay, so now let's go back into this world-aligned material, and I want to create some parameters that I can use to control this from outside the material editor graph. Okay, so what we can do here is very similar to what we did before. Instead of connecting these first to our texture size inputs, what we're going to do is pull off of RGB and type multiply once again. And again, just like we could do with traditional UVs, we can set this to any constant. So I'll make a constant by holding 1 and plugging that into the B input. And if I set this value to 1 and then connect this output to texture size on the world-aligned texture and world-aligned normal nodes, if I apply and save, nothing will change. However, if I right-click the constant and convert it into a parameter, I can call this texture scaling, something like that. And I'll hit apply and save one more time. Now, if I have that set up in this material, I can right-click, make a new material instance, and world-aligned, I guess I'll just leave instance at the end. Okay, and I'm going to replace, let's save that first. I'll replace it on this mesh, and nothing should be different in appearance until I start messing around with that parameter that we made. Okay, so this is just that material instance. You can't see it because it gets cut off by the tab. But I have that texture scaling parameter. And now I can just make this any size I want, like so. And if I scale the mesh, the textures do not squish or stretch or anything like that. Okay? So let me delete this mesh, and I'll delete this mesh, and I'm going to use this material instance all over the place. So let's save it. I could put it on the floor, for example. I could put it on all the walls of this arena. And anything else, right? So if I go in and play the game, I now look like I'm inside of like a brick. And it's cool. You can see the reflection of all of that in our metallic spheres. Everything else is more or less the same, but now I feel like I'm in a brick playground or something of that nature. They probably would not have the floor as brick, but I'm just making the point here. And if I want this to affect my entire scene, at any time, I can just open up the instance, pull it off the dock, and make sure that I can see any parameter or group of parameters that I've set up. And now this is going to affect the entire environment. Okay, it's scaling the textures only, but not the meshes. Okay, that is the key there. And if I hit play, now the bricks are bigger. And they look great. They look very realistic. Even though they're only 2K textures, they look very, very good, at least at this scale. A word of caution, if you are using a texture that you know that you're going to have to scale way, way up in size, and by that I mean using smaller values for UVs or smaller coefficients for your multiplication, then what's going to happen is that they can become very pixelated. So you might consider your texture resolution based on the degree to which you intend to scale them. But under normal circumstances, if you're not going to be scaling them by extreme amounts, then you shouldn't need to do that. 2K textures look fantastic most of the time. Okay, so now we know about regular materials, and we know about, and when I say regular, I mean they at least have an albedo map and a normal map and a way to control their UV scale. We know how to make material instances, and we know how to make world-aligned materials and instances for them, both with parameters that can be adjusted from outside the editor. Do take note, though, that whenever you adjust a parameter, it's going to ask for you to resave that material instance. And if I wanted to make another object here out of the same material, but of a different scale, I could always duplicate a material instance, okay? And we'll number it at the end, and this does not have a 1, but this one has a 1. I could put that instance on that structure, and if I double-click on this, it's basically the same setup, but it gives me a way to scale the bricks on that object differently than the same material, essentially the same material, to other objects that are around it. So that makes it very, very versatile to use. So let's make these into brick as well. Very easy to change the appearance of this world that we are occupying right now. And we can mix it up with these different material instances. This happens to be 4 meshes put together. I think it's just 4. And up here. And up here. Okay. So I'm not going to do the rest, but I think you get the idea. And if I go into play, you can see if I look down at the ground, the bricks are of one scale. But if I look at this platform, they are of a completely different scale. Okay. So hopefully you understand that much so far, because in a moment we're going to take it to the next level. So I'm going to pause at this point, and we are going to switch out our Unreal project, and I'll be opening up Project Aerodel.